Welcome to the UiPath Essentials Training, Data Assembly. Today, we'll learn how to gather data together to produce a desired output. Let's begin. While split method allows us to extract relevant parts from a larger text, there are common scenarios when various data needs to be assembled as text, for example, for logging or when we want to send out an email. There are two ways of doing that, with string concatenation or using string.format. To concatenate strings, we can simply use the plus sign. But if we need to mix various types of data, like for example integers and timestamps, they must be individually converted to a string. All data types have a default toString method that offers a readable textual representation. Let's display a message which contains a static text, followed by a string variable, and let's also append a timestamp. We'll use now, a datetime construct available in Visual Basic, which we will convert to string. Let's run this. And there it is. As you can see, the date is displayed according to the regional settings on our operating system. If we want it to be a different format, we must specify it as an argument to the conversion. There are many options and combinations available, most of them using one or more of these tokens, as listed on the MSDN site. If we want to show the month name and the year, we'll simply add 4 M's and 4 Y's. Let's see. Hello World, September 2018. Great. Concatenation is handy and flexible, but if texts are long or if there's much data involved, the increasing complexity of the resulting expression may be avoided with the use of string format. This method automatically converts data to text representation, and it also supports custom formatting. Let's see how our message would look. First, we set the frame text where data would be inserted. This is the static part. Then comes a data placeholder, followed by another. The numbers inside braces are the positions of data arguments coming right next, but indexed from 0. World, datetime, now. We can also customize the format for the date using the same tokens as before. Now, there are many string methods RPA makes use of. They're easy to handle and understand, so for quick reference, we've compiled a shortlist for the most commonly used. With the exception of starts with, ends with, and format, generic values can also use the following methods. Checking whether a text contains a specific word or phrase. Checking whether a text starts or ends with a particular phrase. Assembling data in textual form. Replacing a word or phrase within a text. Splitting a text in tokens by known delimiters. Extracting pieces from text of known indexes and lengths. Changing text to lower or to uppercase. Removing leading and trailing whitespace. Details about all methods can be looked up on the Microsoft Visual Basic pages for string class. See the link in the video description. Data tables are very important structures and extremely helpful when working with Excel or CSV files. There's a data tables chapter later in this course dedicated entirely to them. For now, let's start building a short example to get our hands around the basic data table concepts. We'll use this CSV file containing tabular data for our automation workflow. The read CSV activity loads the data from the file into a data table variable. Let's call it sample data. We'll make sure that the option include column names is checked so that the first row is interpreted as the column names. The output data table activity converts a data table to a string, which is specified in the activity properties. This string can then be displayed with a write line or a message box activity. In this case, there isn't any unexpected information because we know what the input looks like. However, this activity can be very helpful when scraping data or when debugging. Okay, let's delete these activities and move on to table manipulation. To iterate through the data table, we'll use a for each row activity. To print the names of people in the table, we can use a write line activity. And to get a cell value from each row, we can pull from the row by the column name. The expression looks like getting data from a row dictionary. Running this will output each name in the table. Alternatively, if we want to see the value on the same column for a fixed row index, we'd have to write an expression like this, digging into the table like in an array of row dictionaries. Data table is a complex structure that has many handy methods. Select is a particularly useful one. This method goes through the whole data table, looking for the rows that follow a certain rule, and returns an array with the matches. Let's see how it works. We'll use an assign activity, specifying the table.method used, and as arguments an expression that applies to the data table. Let's say age less than 40 and income greater than 40k. Next, we define a new variable to store the search results. By default, its type is set to generic value. The warning indicates that we need to change this, so we'll choose an array of data rows. To iterate through the array holding the search results, we need to use a for each activity. The rest, referring to the data within a column, is the same as before. Okay, so let's display the name, age, and income using string concatenation. It looks like Paul is the only one who passed the test. This concludes our essential training on data manipulation. Today you've learned about the most frequent data types and methods that you'll likely encounter in your projects. Thanks for watching, and happy automation!